welcome to the Omni ID test labs here on Lexington Avenue in Rochester, New York. I'm Ed Nabrodsky, the Chief Solutions Officer here at Omni ID, the world leaders in harsh environment RFID. Today I want to talk to you a little bit about Active RFID. It's a little bit different from the traditional passive RFID that Omni ID is quite well known for in the marketplace. But we have a very strong offering in this product category, and this technology is of great interest in many harsh environment applications where we specialize. You might have a project coming up where you think that perhaps the conditions are too severe or too difficult to use any kind of RFID, and my hope is today I can talk through some of the advantages of an RFID system on Active and how it can help you in your application. The first thing to recognize is what is the difference between these two technologies. What's passive versus active? Passive RFID is a passive structure. That means there's no power in the circuit. A passive structure is an antenna with a very, very tiny chip that draws its power from a waveform that excites the antenna. When that waveform hits the antenna or resonates the structure, that resonant frequency enables the chip to have enough energy to modulate the waveform and reflect it back, kind of like radar when it hits a structure like a plane or a car. The difference in hitting a radar wave hitting the metal and coming back is that the modulation that the chip performs on the wave is decoded into ones and zeros, and that allows us to read an ID, sometimes sensor information or other useful things from the device. Because passive has no inherent power of itself, it's merely being energized and modulating a waveform, it tends to be useful for relatively short distances, but it is very, very cheap, and it is very effective for tagging many, many items. There is another technology though, and we call that Active RFID. Active is very similar in that it's broadcasting an ID, but the difference is it doesn't have to wait for some kind of transmitter to energize it. It doesn't have to have a resonant frequency that enables the unit to power up and send back the signal. It can be somewhat more autonomous or asynchronous. That asynchronous mode of operation can be very, very useful for many applications. The longer distances that can be achieved with Active are also very useful when you're tagging a large yard or in a large building like a factory or even a large hospital complex where you want to gather signals from a very, very wide area and still be able to maintain control over your assets. So both active and passive technologies have very, very good usefulness in their respective applications. Passive for short range and active for long range. Because active tags have their own power source, they tend to be more complex and thus more expensive. So another reason to choose active versus passive is because you have very small numbers of tags or numbers of assets. That means that the tag cost will not be the overwhelming cost of the project. The advantage to active infrastructure is that it's relatively cheap for a very large area because of long distances you can achieve. So if you've got a large area with a small number of assets, active tagging usually makes sense. If you've got a very tight area, ideally even a choke point like a doorway, passive makes a lot of sense because you have one piece of infrastructure and lots of tags passing through. So those are some of the choices that we make when we choose those technologies. These three tags form a complete family. A family of power tags that enable you to tag your personnel, tag your light industrial assets, your cages, your skids and lids, and also tag your outdoor applications like big vehicles, large outdoor bins. With all three tags, you can complete your entire infrastructure application and tag everything that you have, both in explosion-proof environments and in standard safety environments.